Welcome back, Year 10, to another video. Today we're looking at how to find the distance between 2 points. Okay, last lesson, we found the midpoint. Now we're going to find how do we find the distance between 2 points on a number plane. Okay, let's get straight to it. Plot points 1 and 4 and 8 and 6 on a number plane. So 1, we go across 1 on our x-axis. Okay, and then up 4 on our y-axis, which is going to be here. And then 8 and 6. So we go across 8 on our x-axis and then up 6, which is going to be here. Okay, and we want to find the distance between these points. So if we're assuming, each of these gaps on the number plane is 1, how far is that distance between there and there? Now, this is actually a really important thing to be able to do. In a lot of programming, they would use coordinate-based maths to be able to calculate things. So if you're designing a game or something like that, and you want to be able to calculate distance between objects and things in the game, this maths is used all the time for that kind of thing. We've plotted our points and we need to find the distance. How are we going to do that? Well, we're going to split it up into its horizontal and its vertical components. You see here, we've got a diagonal line. We're going to split it up into its 2 components. What do I mean by that? Well, you can see here, I can get to that point. Instead of going across the diagonal line, I can also move across horizontally and then up vertically, and I will get to that same point. So we've found the horizontal component, okay, how much we've moved across on the x-axis, and then the vertical component is how much we moved up on the y-axis. And what do you know? We have created a right-angled triangle. So we've got a visit from our old friend Pythagoras, who's going to come help us out to find out the distance of our line here. First of all, though, we've got to find how far have we gone across. So the x thing, we've gone from 1 to 8. So how far is that distance? It's going to be 8 minus 1 means we've traveled 7 on the x-axis. So this horizontal value is going to be 7. We've gone from 1 to 8. So 8 minus 1 gives us that value there. How far have we gone up? Well, vertically, we've gone from 4 to 6, so 6 minus 4 gives us 2. You can sort of see how big is the gap, the difference between 4 and 6, it's 2 here. Okay, so now that we have the horizontal component, we have the vertical component, we can use Pythagoras to find out our diagonal component, or the diagonal distance. So remember, our formula a squared plus b squared equals c squared. C squared is always the hypotenuse, okay, or the diagonal part. So here, a squared can be 7 squared, b squared can be 2 squared equals c squared. Okay, now let's simplify this. 7 squared becomes 49. Okay, 2 squared becomes 42. C equals c squared. So c squared is going to be 53, and we're going to need our old mate calculator. Let's get him over here. Okay, then the last thing we need to do is need to square root both sides. So the square root of 53, equals 7.280. Now it doesn't say how many decimal places to leave it in, so we can just leave it as this. The distance between those is going to be square root of 53. If we were to round it off, we could say equals 7.28, and that's to 2 decimal places. Okay, so we found the horizontal component, we found the vertical component, and then we use Pythagoras to find that distance. All right, now here, we're doing the same thing, except we don't actually have to plot the points for this one. So we're just going to find the distance between the horizontal component and the vertical component. Now, if you want to, you can plot those points and have that visual aid as well. And I'm not going to discourage you from doing that, but I'm going to show you that you can do it without plotting the points. So first of all, we're going to find the horizontal component, or the x, and it's just going to be the difference of these two values. So it's going to be 4 minus -5. Now, because we've got a double minus, okay, the horizontal component is going to be 9 between these 2 points. The vertical component, okay, we've gone -2 minus 8 is going to be -10. Now, if you get a negative number, it doesn't matter because we're going to be squaring it anyway. So we can still use that as our value. So to find out, we're going to use this old equation. Our horizontal component is 9. So 9 squared plus -10 squared equals c squared. This becomes 81. This becomes 100. And that stays there. So c squared equals 181. C equals the square root of 181. Now, what is that going to be? Square root of 181 equals 13.45 to 2 decimal places. So C equals 13.45. That's to 2 decimal places here. Okay, so you've got to find the difference between the x's, the difference between the y's, and then use Pythagoras to find the distance of our diagonal line there. Okay, let me know if you have any questions, and I'll see you in the next video.